So as far as materials go, the common ones that we've seen on the race course probably would be wood, aluminum, fiberglass, and then probably inflatable cloth would be the fourth one that I would see most likely. And I think we have seen some carbon fiber and some other composites out there. So just kind of some of the advantages and disadvantages. Depending on what your facility has the capabilities of working with is probably one of the things that really outlines, is that a good material for you to use, unless you're not planning on really doing much of anything to modify it. But like, let's say, for example, you have an aluminum boat or something like that, and you wanted to be able to make changes to the hull, you would then need to be able to TIG weld aluminum or in some way modify that if you wanted to, change the shape of the transom or do something that, change the shape in some way. But if that's not something, and we're not suggesting that people shouldn't necessarily be doing that, but if that's something you want to be able to do, then that's a reason why you wouldn't go with aluminum. Things like wood are pretty commonly, easily, worked on with hand tools and different tools. They're also pretty forgiving budget-wise. You could try things out, see what works and what doesn't work, and iterate on that without spending a bucket load of money. When you get into sometimes composites like fiberglass, especially things like Kevlar or carbon fiber, where they're, the material itself is significantly more money. You can pay a lot of money to make mistakes that you'd have to take off the boat later if you decided that you needed something slightly different in shape or weight distribution or whatever those changes would be. So, and then the other category, the inflatables. There's pros and cons to inflatables. Most of the inflatables on the market, I would say, that are in the sort of I don't know, use the brand name Zodiac, but the sort of U-shaped, hull with a floor that fills in between. I think they were sort of designed initially as tenders, as these boats that would be able to go to and from larger vessels to shore. And they aren't necessarily the most efficient hull shape, but if you get one with a high pressure floor or one of the ribs, the rigid inflatable boats that have a fiberglass or aluminum floor, then the actual part that rests on the water is, essentially the same as a hard bottom boat. And so then you have the advantages of all of that extra freeboard is this lighter weight material that weighs very little, it's very buoyant, and it's forgiving if you're shifting around and moving around in the boat. And so there could be, in fact, we saw one of the teams this past year had a Takacat, catamaran inflatable that was very fast. And, they're very light. They can carry a significant size motor, especially considering what their weight is. One of the challenges of that is there's not as many easy ways to attach things to the boat. So you have to think about how are you going to strap your batteries down, how are you going to mount your things that, other than the motor that can bolt onto the transom, which is a pretty fixed part, but you don't have that sort of rigidity. It does all tend to flex and move around, and they're a little less forgiving if you run over something in your testing and pulling it off the ramp and everything. So in longevity, maybe they're a little bit more to be careful with, that they don't get wear through from pulling it up on a shoreline or something like that. But that aside, I think that the inflatables can be very very good competitive boats. And one of the advantages of inflatable boats is that, especially if they have an inflatable floor or a removable floor, they can fit into a trunk of even a regular car. You could manage to cram all of your stuff into your typical, sedan, let alone having a pickup or a van or something like that. So if you're going a longer distance and pulling a large trailer becomes more cumbersome, you could have a team van, and then all of your stuff could be in the back, including a collapsed down, inflatable boat. And if you've got one with the rigid hulls, then usually that center section doesn't collapse down. But, considering that the inflatable tubes are, usually between like 15 and maybe 18 inches in diameter, you subtract that off of the ends and the sides of the boat, so you do get a smaller boat that perhaps would fit into the back of a van or easily into the back of a pickup or something like that, where a 17-foot, monohull boat, let's say, for example, would be kind of hanging out of the back of any truck to a degree where maybe it wouldn't be as easy to take that without a trailer.
Yeah, I think design-wise, teams have to think about, well, there's always trade-offs with time and money, right? And so some of that's your time, some of that's the money, the budget that you have. But it's trying to figure out the lightest craft that has the rigidity that you need, and then trying to think about the surface area of the water that's interacting with your craft, because that's your drag, but then counteracting that by having stability, because you do have to take 9 lefts. So you want to, and so that's where like we see a lot of catamaran designs in the unmanned, because it provides that stability with the ability to have redundant motors touching the water.
That's a good thing to bring up, that when you're talking
Yeah.
about hulls is when you have your drivetrain where it's not a centralized propulsion with a rudder, and you've got twin motors, then I don't know, I would call that like tank tread steering from the land-based version. But the way you turn is by vectoring power on and off on one side versus the other. Then the way you turn is essentially slow down.
Right.
Whereas if you could take all of the thrust and just change the vector that you've got it aimed, you don't necessarily have to throttle back to go around the corners. And the other downside to that is if for some reason the boat is not perfectly balanced, that it naturally wants to turn one way or the other, you're constantly essentially throttling back on the faster side to let the slower side catch up. And so in that situation, where you could just go down the course with your rudder slightly off center to compensate at your maximum thrust that you could do. With twin engines like that, you're always limited by the boat wants to naturally spin out one way or the other because of something with the weight distribution or whatever it might be.
Yeah, I think those teams often have to do a lot of testing to figure out how it operates in the water. And then a lot of times they reset the controller to have 84% as 100%. So that way the controller is already designed to compensate for the known issues with the system. And I thought it was pretty interesting that like we talked for 3 minutes before we start talking about testing. Like the real thing of this competition is to put things in water, put things on bench power, and always be like seeing what happens, because it's definitely a lot of problems that show up during the testing.
Yeah, and that's one of the things that I feel like you see so much at PEP is, there's the what was planned to happen and then what happened, and how much of the unexpected things that happened because the testing wasn't done in advance, or it was, they did plenty of testing and there's some random other thing happened, which happens, that
well,
I
it's,
think happens too.
it's what happens in all testing, right? You test things and you make some design changes, and it some ways is a carry on from the old test, but in some ways it's a brand new test, and it's going to have brand new issues, and it's going to, so like.
Well, that's a good thing to bring up also, is with iterative testing and changes, one of the things that we've found that is common sense, but in hindsight, makes it a lot more difficult when you're comparing how did what I just did affect in a positive or negative way. When you change multiple things and you have multiple variables that are being fluctuating, then it's a lot harder to know what about what I just did made it better or made it worse, and so if you're doing changes like that, and if you can afford to do one at a time, if you're going to change, let's say, your hull, and you can afford to not change out all the propulsion stuff without too much difficulty, just see, does this other hull or does this change to your hull make the boat overall faster, slower, plane more easily, like all these different characteristics, and then change the next thing, because if you change multiple things, it's too hard to know why you have the effect that you necessarily did. So So, and with planing hulls, just keeping in mind that the power that you need to get at planing isn't necessarily the power that you need to sustain a plane. So you might find that in a case of a temperature, power consumption and elevating temperature situation, you could use additional power that you may not be able to afford to be able to use for the entirety of a race to get established on a plane, and then you can throttle back to a cruising speed, a racing speed, but not wide open, if you find that the wide open speed is going to not give you the range that you need to complete your 5 miles. And that's all part of the testing, like knowing at what point you can get on plane, and then what your power consumption levels are at different speeds, and figuring out, how fast, what is the fastest that you can manage to go and be able to go the full 5 miles, and then keeping in the back of your mind, what were the conditions when you tested it? If it's a perfectly calm day and then you're out there at PEP and there's chop, and every time you splash and you throw a wave, you've just consumed a little bit more energy, so keeping all that in mind.
I think every year a few teams come with the idea of a hydrofoil. And it kind of has what you were just talking about as like design considerations, because you have to get up on the
foil-borne,
and then you have to operate it differently. So it's kind of like designing two operating systems, right? Like The teams have to be able to manage that first part, and then also have the same craft manage that second part. So it's a pretty complex design. The other thing that's a little bit of a risk with those hydrofoils is that the most important parts are under the water line. And the one time that we did see a hydrofoil at the competition, that was the issue. That wasn't waterproofed, and then we didn't need to get it off the boat because the race was over at that moment, right? So hydrofoils are definitely an option for teams. They're very complex. So if that's the thing that kind of like inspires you to be in this competition, it's worth what to go for. But just have a lot of plans for a lot of testing because it is a complex piece of machinery or equipment to work.
Yeah. I guess one of the feelings that I have about hydrofoils is that if you're talking about what is the sort of most efficient hull that you could use, hydrofoils are definitely a more in consideration because once you're foil borne, you lose so much drag.
Right.
But if you don't necessarily have the same restrictions on all of the other, if this was a competition where you were limited to a certain size and weight propulsion system, then it would make a lot more sense for everybody to be going to foils.
Right.
Because then you could go faster and further with a more efficient hull in that way. But since that is not necessarily the case, the complexity that comes into being up on foils, you're basically trying to fly with them below the surface of the water because when you break the surface of the water, there's more drag and they don't work as well. But every time you crash down with with the hull itself touching the water, you've got increased drag. And so there's are you going to have that sort of leveling, that flight height automated, or is that going to be kind of flying by the seat of your pants while you're trying to manage all of the other aspects of driving the boat in? So, that's a very cool technology, and something that we've been interested in exploring, but I don't think we're ready to bring that into the competition just yet.
Right. I think the last type of design that we hear a lot of teams have the advantage of looking at is a catamaran design where they get for fairly cheap, $100, $500, someone's sailboat that they no longer want. And I think the only thing that design underlines is that lighter's better. And so like stripping every part that isn't structural off that thing and then figuring out some way to address like what you were talking about with the inflatables of when you have a blank canvas with a lot of flat surfaces, you need to add some rigidity and some containers that can protect your materials that are so heavy and valuable.
Yeah. Our team started out with a Hobie 16 catamaran. That's our very first hull, and we actually never took that to competition. We switched out of that before in our testing phase. And one of the reasons that, in particular, we didn't like the Hobie 16 was that they have asymmetrical hulls.
Right.
So if you think about it as a sailboat, as they get going faster, they're going faster because the wind is increasing and the sail is naturally getting it heeled over. And so as it's heeling over, as the wind is pressing sideways against the sail, the boat wants to, sort of not go straight ahead. It wants to kind of fall off, veer off downwind, so to speak. So without having a centerboard or, keel to it, they achieve that by these asymmetrical hulls, and the hulls themselves are more curved on the outside, so that way as they get more pressure on the leeward side, they tend to scoop you back up and keep you upwind, which works great when you're sailing. But when you're driving it flat and fast on the water, as you get it going faster, it's sort of like pushing more water around those asymmetrical hulls, and you're wasting some of the energy in doing that.
Right.
And so we actually found that going at greater speeds, as the boat tends to rock and you tend to bury one of the hulls more than the other, it will tend to be all squirrely back and forth because you're shifting which hull is actually biting more at the time, which just goes to show how much they're actually pushing side to side, and you're fighting constantly to push the water around the hull. But the other reason that we moved away from the Hobie 16 was that we were using about a 200-pound battery at the time from 16 lithium iron phosphate cells, and the weight of that plus the driver. And we also had a plywood deck to keep the water from being able to come up and splash underneath of everything. So with the weight of all those components plus our motor below it, we were just sitting a little bit too low in the water, and we felt like we were sort of dragging, the too much of the boat in the water. So there are other sailing catamarans that I don't believe have that same situation. Like I think the Prindle line of catamarans in that same size, the 16-footers, for example, I'm pretty sure they're symmetrical hulls, and there's a lot of other symmetrical hull boats out there, some of the more modern ones but the Hobies and the Prindles are two of the ones that I feel like there's enough of them, older ones that are around, that you can get them for next to nothing, used online, and so they're definitely something to consider using.
Yeah, and I think the last principle just to touch on is how long a craft can be,
Mm-hmm.
and with the benefits of length when you're looking at speed. Can you just talk about that a
Sure,
little bit?
sure.
Yeah.
So with a displacement hull, you've got the water line affecting the theoretical hull speed. And so with a boat reaching hull speed, it's basically at the point where the bow wave is sort of rising up at the stern of the boat. And as you try to push beyond that theoretical hull speed, you can push beyond it, but you have
Right.
this drastic increase in power consumed
Right.
with a minimal increase in speed achieved. And the reason is that you're basically pulling this huge stern wave up behind you in the process of doing that. So if you're going to have a displacement hull, you want to make sure that you've got a long enough water line that the hull speed is fast enough for what you want to do. The caveat to that, I guess, is when you've got a extreme ratio difference between the
Sure.
width and the length, like a rowing shell is a good example.
Right.
Boats like that tend to be able to get away with blowing past that theoretical hull speed with more forgiving performance. They don't tend to drag up a stern wave the same way. So like a typical sailboat hull, I guess it maybe would be, with the rounded, very rounded bilge and bottom, and the transom comes up in a nice gentle curve. They're very effortless, easy to push through the water.
Right.
But they tend to pick a really large stern wave, whereas maybe a more modern sailing catamaran or a rowing shell or one of these other displacement hulls that have that really long length to width ratio, they can get away with it a little bit more.
Yeah, I remember speaking with some of the boat builders at Y Island
Mm-hmm.
a couple years ago, and they were speaking to the idea of that if you get over 5-to-1, that ratio.
It's a different class
Right.
in that, yeah.
And it just starts to get a little bit more squirrely.
Mm-hmm.
And even like 5.5-to-1 maybe they were saying, but
Mm-hmm.
you got to be careful. And what we've seen in the unmanned is that sometimes just having like almost like what the Naval Academy had when they were at Y Island
Yep.
last year, or even a little bit lower where it's a little bit providing a little bit more safety stability, can help you be prepared for that worst case. But then that's why so many teams end up with catamarans, because it takes that length, but then makes it a stable platform. So,
Yeah. So the disadvantage to a multi-hull is that you've got double the length of water contact. So
Sure.
when you're talking about how much surface area is the water rubbing by as you're making contact going through the water, if you had a trimaran, then you've got three sides of hull that you're pulling through the water.
Right.
The boat, and so then is it worthwhile? If you had the equivalent of a monohull in length to width ratio, and then you tripled that in width, then you've got an awful lot of drag. Whereas
Right.
if you had relatively narrow hulls, so our current trimaran that we have at Washington College, the center hull is built on the front 23 feet of what was a 60-foot carbon fiber rowing shell. So we've got 23 feet of hull, and the first, I want to say, 7 or 8 feet goes from that skinniest little point to about the roughly, not quite the maximum. It does max out at the stern, but it gets to be almost the max at the point where we're bringing it into the cockpit area. And that's only about 18 inches or 16 inches wide or something like that.
Right.
By the time it gets to the transom, it's probably closer to 20 or so inches, I believe. But that would be very, very unstable. We wouldn't be able to safely do that with the weight of every propulsion, batteries, and the driver and everything without having those AMAs. And
Sure.
so our AMAs are from a sailing catamaran, which was a sort of lesser known one, a Boston Whaler Supercat. And so it's a 17-foot Supercat hull. Those hulls have a little bit more volume than like a Hobie 16. Even it's a foot longer, but they have more volume anyway, so that it does, I guess, add sort of a better weight carrying capability. But they are also symmetrical hulls, so they slip through the water pretty nicely. And we found that it handles varying sea conditions pretty well. We actually had it out on the bay about 3 or so weeks ago to doing some distance testing, and we found that it handled fairly choppy water better than our chase boat did, which is a 27-foot Boston Whaler with a full enclosure and
Sure.
everything. It was surprising how well it handled in those conditions. But not every hull. I guess this is the takeaway is not every hull is ideal for every situation.
Right,
And
right.
so what you probably, in our case of that trimaran, it wasn't necessarily designed specifically for PEP. We wanted to be able to do the PEP competition, but we also wanted to do other things beyond that. So if you're designing specifically for PEP, then I wouldn't necessarily look at what other people are doing and say, oh, that looks like a good fast boat. Let's do what they're doing. Think about what sacrifices have they made to do that.
Right.
Sometimes a fast boat it could be competitive, but the same propulsion in a different hull, maybe even faster, because that trimaran, for example, is capable of maybe rougher conditions than we would really expect to see at PEP.
Sure.
And that is a sacrifice that that we are suffering a little bit because of that.
Well, and I think the trimaran has. So the one thing that I speak with the teams a lot about is how important reliability is. That as much as it does sound like a race, it really is an endurance competition. And most of the times that we tow someone off the track, it's because something came loose or something just didn't go as planned.